Hey everybody, this is Dark Guardsman, and we're back with another video. Now, I finally got the thermal system done for Atomic Science. So I'm going to go ahead and show that off here and show how it kind of works. So for those who are not familiar with the mod, Atomic Science basically is a mod about reactors and generating power with reactors, doing various things with them. But the main core concept of it is that you have a reactor that will generate heat that will then cause water to boil and everything else. In the original mod, how this really worked is it just kind of scanned blocks within radius and it would melt them down or cause heat or whatever. The last version that was ever produced by Calclavia, how it worked is it had a very simplistic heat system in it, where it would try to spread heat around, move it around, kind of give you some kind of thermal system. That was a system designed by me, Max Wolf, and Calclavia. It kind of worked somewhat decently well. Was not the greatest thing in the world, but it did actually result in some good gameplay. The new system being implemented is a pathfinding based thermal system. It actually will allow heat to transfer as if it was kind of in the real world. It's not a perfect system because of course we're in Minecraft. I have to make some allowances for the gameplay mechanics and the expectations that you will be playing inside of a game and everything else. But it is really close. It actually does use realistic values to calculate how much energy needs to be generated to actually heat blocks and melt them. So those values are actually pretty spot on. The values that are not 100% is how much heat would transfer, because after all I have to make some changes to make it where it kind of gameplay wise fun. Right now, how the Pathfinder works is what it'll do is it will start from the center block here, and it'll just work its way out, and every time it hits a block it'll go, okay, how much heat do I have around me? And it will then set the heat value based on that, and it'll take away that heat from where it was connected to. So say we were right here and there was a reactor on all four sides, it will pull heat from all four reactors and generate a actual decent heat value right there, and that will be pretty consistent. Now the Pathfinder does only work on one reactor at a time, but the values are added together on the map, so you will get something that looks like it's all four reactors running, but it is one at a time and it does work really well. Now we do have the heat probe. The thermostat actually does work. This will actually tell you how much heat energy is there. The reason why there's two values for heat is the left side is the heat actually placed in the map, and the right side is how much heat we're getting from the environment. So how much the biome's giving you, the world, everything else. And that'll tell you how much base heat you have. That is based on room temperature, so whatever the room temperature value is set for the world is what that's set for. It'll then tell you how much the temperature is in Kelvin. I will be allowing this to be changed to Celsius and Fahrenheit, just so you guys can get something very simple. And then the last value right there, the HTM, which is heat to melt, it will tell you how much heat is required to melt that block or everything else. Now, by default, it'll say 0 because that block is not meltable. But say, for example, we put down ice right here, and we right-clicked it, it'll tell us that it takes 909 million joules of energy to melt, and of course the block will melt as it's placed. Now, one quirk with this right now that I am currently working on fixing is that when this block is actually placed, it will not melt right away until I right-click it and it'll disappear. And this is a kind of a problem with detecting block placement that I'm currently working on. So I can't actually detect that block being placed properly, but I can detect interaction with it. So if I right-click and I do that. I do have a solution for this because VoltSengine actually has code built into it for this. Unfortunately, Atomic Science is not built on VoltSengine, so I'll have to go ahead and grab that code and bring it over to Atomic Science and utilize it. But the cool thing is we can actually put ice around here and put this around here and it will work. And if we actually take the core out, the heat values will actually reset, so we've got 0 joules of energy around here, and I can build up a lot of ice around here. And we can actually surround this thing, I believe, all the way with ice, and it should melt the layer above it. Heat is spread evenly in all directions. It actually will spread about 12% to the connected blocks and about 2% to these core blocks, creating a pretty good heat spread. Now, may I note the heat is done per block. So heat that will spread from this block will then spread heat to these connected blocks and so on, allowing the heat to migrate out. The cool thing with this as well is that the amount of heat that's actually coming out of the reactor is somewhere around 15 gigajoules, but when we actually stick the rod in there, you'll notice it actually is 1.2 gigajoules. This is part of the heat spreading, so what it'll go is, okay, I know I can generate 15 gigajoules per tick of energy. I now need to spread that around, and it'll actually calculate that spread, and it'll actually calculate how much energy goes from one block to the next and so on. Let me go ahead and remove this out of here again and replace this all with ice, because I knew I was going to do that and I didn't actually do that. Now, there will be a lot of systems in place for this when this actually is fully done. The way this is being designed is that you can be as creative as possible with how you design your reactors. This means that you can do a lot of different things. You don't just have to think of your reactor in terms of how much water I need to stick around it. You can also think of, okay, what materials do I need to build the shell of the reactor out of, because the shell will matter. So if you build it out of brick, keep more heat in there. You build it out of metal, it'll actually migrate more heat away. But also you have to keep in mind that the material shell you build the reactor out of also matters to not just how much the heat transfers, but how much radiation leaks out of it and everything else. Let's go ahead and surround this with ice here. I need to make sure I leave the top block open or I won't be able to stick the fuel rod in. And we put that in, and there we go. Melts all the water. Really cool trick you can do with this, because of the way this is designed, you can actually build your reactor with ice to start with and actually flow it out. Now this actually has a really good range on it too. By default, I think it's locked to 50 meters of range just to keep the thread from overdoing the CPU. So end up using too much CPU. Right now this actually does run incredibly fast. And if we actually go down here, it'll run, yeah, so that was a, oh, that's the radiation thread. So the radiation thread ran in 850 milliseconds. But that was for 300,000 radiation, which is a pretty large distance. For the amount of heat that was spread here, which is 31 million joules of energy, it mapped 6,920 tiles, and ended up taking 120 milliseconds. For reference, it took about 2 ticks to calculate that, so each tick is about 50 milliseconds, a little bit, actually 2.5 ticks. But that's pretty good when you think about it, how many blocks actually mapped over. Almost instantaneous response time. As soon as that rod went in, it almost immediately cooked off. Now we can put that in there all day, take it out, put it back in. You don't want to spam this, by the way. It actually can cause problems if you put it in too fast and put it back in. I probably will be putting a delay in there how quickly you can remove it, because there are some problems where if you put that in a little too fast, you'll get really fast overtick, and it will actually cause the heat map to not update properly. But we actually will get heat all the way out here. And you can see the temperature as well. So 290 is where I've got room temperature set to, but about 300 is about room temperature. So that's about a comfortable range. So even like we get all the way up to here, we're still within somewhat of a comfortable range where you can stand without dying. There is a point when the heat would get too hot that you would actually die. I probably am going to put that game mechanic in there. Of course, you'll mitigate that by just simply wearing the suit. So the actual environmental suit here, I will actually be making that also act as an insulator from heat. And we'll probably be even putting respirator abilities on that as well. But that's a bit what I've got to show here. So with this actually being done, this means the reactor is capable of running now. The only thing I got to do is calculate how much steam is produced, and then actually put the steam turbines in there and everything else. So I'm actually probably going to start with the steam funnels first, because when I get the steam funnels done, then we can hook it up to something like Railcraft and actually start producing power with it. So I'll get that done and released, so that way you guys can start toying around with the values and seeing how the reactor behaves. One thing also with the reactor, there is planned to make it work with a kind of heat fin type system. So if you actually put metal blocks around here, I don't know if I even got a metal block here to use. I know there's one in the game. It's not actually programmed for this behavior just yet, because I got to actually add the heat transfer rates. But if we got an iron block here, the concept would be is that what you could do is stick this iron block next to the reactor, and this would actually improve the amount of heat transfer from around it. So that way, if you wanted to build a really large reactor but didn't want to have all the cores spread out through the reactor and just want to have one core and some heat fins, the ideal would be that this would work. And it would work off a very simple mechanic that the amount of heat transfer between water and iron would have a much higher heat transfer. Therefore, much more energy would flow into the iron block and then out into the water. And I may even add special code just to make sure that actually works much, much nicer. Anyways, I'll leave you guys here, and I'll be back with more videos and content, hopefully a released version of this sometime by the end of this week.